Now water is a molecule, H2O. It's two hydrogens with one oxygen. It's the chief liquid in all biological systems. Now also, in the way that things come together in these bonds, and because there's repel, not everything is all linear in the molecule. So a water molecule actually looks like this. All of the fluid in your body is water-based, and basically our body is made up of about 65% water. Water is polar solvent. It bonds between the hydrogen and the oxygen are polar covalent. So because it's not linear, you get this kind of angled thing. You actually get a little bit of charge on each end. The oxygen takes more than its share of electrons, so this end is slightly negative, and these ends are slightly positive. Charged molecules containing elements like oxygen, phosphorus, and nitrogen mix easily with water. So if something mixes with water, it's known as being hydrophilic. Phile is a word stem that means to love. So hydrophilic means water-loving. Other molecules which do not carry a charge, like fats and oils, do not mix well with water. Those are known as hydrophobic. Phobic, fearing, doesn't like. So you probably know from home, oil and water don't mix. If you're making salad dressing, you get layers, they separate. You have to shake them violently, vigorously, to get the water and the oil to mix just for a minute to pour your salad dressing out. Here we have a carbon dioxide molecule, and we see that a carbon dioxide actually lines up in a linear form, and then we have the molecule will have a non-polar bond because it's all linear and symmetrical. But here with the water molecule, like I drew on the other page, you have the oxygen, and then off in an angle behind it, kind of like a tail, you have the hydrogens. So that creates a polarity. So the hydrogens have more positive because all their electrons are attached to that oxygen at this end, so the hydrogen positives are out at this end, and because this has excess now kind of taken charge of those electrons, it gets that negative charge. Polarity of water causes development of hydrogen bonds between water molecules, and the hydrogen on one end of the water molecule weakly binds to the oxygen on another water molecule. The bond between water molecules increases water's heat capacity. So they're bound together very easily so they can pass on the heat. Water can actually store heat, and water heats up and cools down more slowly than air.